Okay. Woo! I'm a Helu Hazelton from the 403 to the HAZ, Mr. Nelson. Back in the house, Happy New Year. Okay. It's been a while since I made a video, so I am just psyched right now. Okay, linear systems of equations. So, prior to Christmas, we got to know this beautiful equation. Y is equal to mx plus b, where m is our slope, which we calculate as x2, x1. So x2, y2 is a coordinate of a point that is further along the positive x-axis, and then x1, y1 is kind of like our origin point. So when we're doing this stuff, if we have a line or a couple, if we have two different lines like this, for example, if I was doing the slope on this line here, I would take this as my point x2, y2 because it's further along the x-axis, positive. And then this would be my x1, y1. Or if I was using this line here, again, I would use this as x2, y2 because it is further to the right. That's going to be the point I'm going to use for x2, y2. And then this would be x1, y1. And then B is our y-intercept, where both, this would be my B here, this would be my B here. Okay? We're not going to talk too much more about this. I just wanted a brief reminder because when these are linear equations. Now, what happens in the situation where I have a system of linear equations? Well, so say I had x minus 4y equals 1 and x minus 2y equals negative 1. There are two linear equations here. So now we call this a system of linear equations. And when we solve, if I were to say solve this system of linear equations, basically I'm asking you to figure out what x equals to and what y equals to. Okay? Here is the golden rule. Never forget this rule. I'm about to give you some gold. I can solve a system of linear equations as long as the number of variables is smaller than the number of equations. Sorry, is smaller or equal to the number of equations. So how many variables do I have in this system of equations? Well, I have x's and I have y's. So I have two variables. How many equations do I have? I have two equations. 2 is equal to 2, so yes, I can solve this system of equations. And what is the solution? Well, I don't know what these would look like graphed, but let's just pretend that they look like this. So if I have one linear equation that looks like this, and it would go on for infinity, and I had another equation that does something like this, the solution is going to be the coordinates, the xy coordinates of the intersection, where the two lines intersect. That is what my solution is. And this comes in handy when we start working with word problems and we're determining kind of like a optimization, min-max related issues. And we'll talk about that in a future video. But for now, this is what we need to know about linear systems of equations. Okay? So when we start to solve these things, there are two methods. Okay? There's two methods. I can use either substitution or I can use elimination. Now, full disclosure, when I was in school getting my engineering degree, I never used elimination. I always used substitution. I I believe that substitution is a much more versatile and powerful method. Elimination is, as far as I'm concerned, something we learn in high school to make your lives miserable, but it's actually not so bad. So substitution. Let's talk about substitution first. In order to do substitution, here are the steps, okay? You're going to follow these steps religiously. Step 1, choose an equation from the system of equations. Choose an equation, okay? So we can say we call this 1, call this 2. You got to choose one of them. Choose an equation. Step 2, now choose a variable. And step 3, so in this case, if I chose a variable, I could choose x or y, okay? Step 3 is isolate that variable in the equation you chose. Okay? And then 4, substitute for the isolated variable in the other equation. Okay? A lot of words. What does this look like in practice? Well, let's just follow the steps, shall we? So in the next video, I'll do elimination. Let's just focus on substitution for this video. So I am going to choose an equation. Okay, bum, bum, bum. Okay, I chose 1. Now I'm going to choose a variable. Well, if I choose equation 1, which of these two variables looks like it will be easier to isolate? I think x. Because in order to isolate x, all I have to do is add 4y on each side, and that will get rid of the 4y. And then I'm left with x alone. So plus 4y, plus 4y. I'm just going to uncircle these so it looks more clear what's going on. So, if I isolate for x in the first variable, I get x is equal to 1 plus 4y. Okay, and I'm going to put a little dotted circle around that because I'm going to come back to this. So, we've done steps 1 through 3. Now step 4 is substitute for the isolated variable in the other equation. So the other equation is equation 2. So in equation 2, every time I see an x, my isolated variable, I'm going to replace it with 1 plus 4y. So let's do that. Well, x, so 1 plus 4y minus 2y is equal to negative 1. 1 plus 4y is what x is equal to. So I can replace x with 1 plus 4y. Okay? Now I'm going to add all my y's together. So I have 4y minus 2y. So that's 2y is equal to negative 1. Now I'm going to isolate for y. So I'm going to get rid of this negative 1 by subtracting it on either side. And I get 2y is equal to negative 2. And then I divide by 2 on each side. And I get y is equal to negative 1. Boom. Okay, so I figured out what the y coordinate of my intersection is. Now to get x, I just use the equation here. So x is equal to 1 plus 4y, and y is negative 1. So x is equal to 1 plus negative 4, negative 3. So the solution to this system of linear equations, where they both intersect, is at negative 3, negative 1. Okay? That is substitution. Let's do another couple examples, shall we? And I'm going to leave my rules there. My steps. Okay, here we go. So let's try. I've got x minus 2y is equal to negative 6, and 3x minus y equals 2. Okay, there's my two equations in this case. So I have two variables, two equations. I can solve this. So let's see here. I'm going to call this 1, call this 2. Okay, let's see. Let's change it up. This time I'm going to choose equation 2. And I'm going to choose y. Because in equation 2, y actually looks like it'll be easier to isolate for because it doesn't have something I have to divide out at the end. So I chose 2, so let's isolate for y. I have 3x minus y equals 2. I am going to subtract 3x from either side to get rid of that, and I get negative y is equal to 2 minus 3x. And then I'm going to divide each side by negative 1 to get rid of the negative there. Divide by negative 1, divide by negative 1. I get y is equal to negative 2 plus 3x. Now I could have done this a different way. I could have done this 3x minus y is equal to 2, and I could have added y on either side to make y positive, and then I could have subtracted the 2, which would have given 3x minus 2 is equal to y. 3x minus 2, 3x minus 2, or negative 2 plus 3x, same thing. So this is what I'm going to substitute for y now in the other equation. So I'm substituting for the isolated variable, which is y, in the other equation. So I go to the number 1 now, and I say, okay, x minus 2y minus 2, but y I'm going to replace with negative 2 plus 3x is equal to negative 6. Now I'm going to expand this x, negative 2 times negative 2 plus 4, negative 2 times positive 3x is negative 6x is equal to negative 6. Now I'm going to isolate for my x's. I'm going to combine. I have 1x minus 6x is negative 5x. And then plus 4 is equal to 6. And I'm going to move that 4 is equal to negative 6. So I'm going to subtract 4, and I get negative 5x is equal to negative 10. Divide by negative 5, divide by negative 5. I get x is equal to 2. And then I go back to y, my equation for y, to figure out what y is when that x is there at 2. So I get negative 2 plus 3 times 2, y is equal to negative 2 plus 6 is 4. So in this case, my intersection, or my solution, is at 2, 4. X is equal to 2, y is equal to 4. Not so bad, right? Just a lot of accounting. Taking care of numbers here. So one last one further. Okay, one last one further. And actually, a little cup of coffee for the boy, for the peach. This is turning out to be a longer video than I anticipated. Okay. So, one last one. Let's try. So let's say I have 3a plus 2b is equal to 5, and 2a plus 3b equals negative 1. Okay, again, I have two variables. A and b are my variables. And I have two equations. So yes, I can solve this. I have the same amount of equations as I do variables. So let's go through my steps. I'm going to choose an equation. Flip a coin, comes up heads. Okay, I'll go with A. I'll go with the first one. Okay, I chose that one. What variable do you guys want to do, A or B? B? B it is. I mean, they're both going to be difficult to isolate for. And this one's going to get real messy real fast. You just watch. So I've chosen equation 1. I've chosen B. Let's isolate for B. So I get 3a plus 2b is equal to 5. I'm going to subtract 3a from either side, so I get 2b alone there. And then I get 2b is equal to 5 minus 3a. And then I divide by 2. get b alone. So I have b is equal to 5 minus 3a divided by 2, or 5 over 2 minus 3a over 2. There's my relationship for b. Okay, and so now I take this equation, I substitute for b in the other equation. So I did a 1 here, so I'm going to go to 2 now. And every time I see a b, I'm going to replace it with this mess. So I have, I'm going to do this in red so you know where. So I have 2a plus 3b, but b is this mess. So 3 times 5 minus 3a over 2 is equal to negative 1. Now I'm going to expand this. 3 times 5, so I have 2a plus 3 times 5 is 15 divided by 2. Minus 3 times 3 is minus 9a divided by 2 is equal to negative 1. Okay, I'm going to erase this now because we're not going to do another one. So now I'm going to show you where we go with this one. Because now we're getting into some algebra, where we have to actually kind of know what we're doing. Okay? So this looks really scary, really messy. And ultimately, I'm just trying to solve for a. So in order to solve for a, having a denominator or having a fraction, it's no bueno, no bueno. So what do I want to do? Well, I want to get rid of this 2 down here, because I don't want fractions. I just want a nice, something like this. Nice and, I don't know what the word is, but easy to work with. So how can I get rid of this 2 down here? Well, I can multiply the whole equation, because what I do to one side I have to do to the other. I can multiply everything by 2. And in doing so, when I do that, this is what happens. Well, I'll get 2 times 2, I'll get 4a, and then this 2 is going to cancel with this, because 2 times 15 is 30, divided by 2 is 15, so plus 15, and then the same thing's going to happen here, because 2 times 9 is 18, divided by 2 is 9, so that goes away, and then I just have is equal to negative 2, because 2 times negative 1. Now I can work with this really easy. 4 minus 9, I have negative 5a's plus 15 is equal to negative 2. And I am going to move this 15 over, so minus 15 on either side, and I get negative 5a is equal to negative 17. I'm going to divide by negative 5, so I have just a, and I get a is equal to 17 over 5, because negative divided by negative is positive. Not a very nice whole number, but that's the way the cookie crumbles. And now I can take this back here and put that in for a to figure out what b is when a is 17 and a half. 17 over 5, I'm sorry. So let's do that right here. B is equal to 5 minus 3 times 17 over 5 divided by 2. Yuck! That is gross. So I actually don't know. What's 3 times 17? 45, 51. 3 times 17, 51. So let's get this out of the way. So b is equal to 5 minus 51 over 5, all divided by 2. Well, let's finish what we started. Okay, I'm going to split these. So it's going to be 5 over 2 minus 51 over 5 divided by 2, which is the same as 5 over 2 minus 51 over 2 times 5, or 10. 2 times 5. And then I'm going to convert this into a fraction out of 10 so that I can do the subtraction. So this is the same as, well, 10 times, or 2 goes into 10 5 times, so 25 over 10 minus 51 over 10 is equal to negative 26 over 10. So B is equal to negative 26 over 10. Ugly. Mr. Nelson would never give you a problem that got this ugly, or would he? Probably not, but I might on a quiz. In any case, this is substitution, and as a reminder, these solutions that we're getting represent where these two linear equations intersect. Now, these are not in y is equal to mx plus b format, but they could easily be put into it, because I could call ay or by. So let's say b is my y. Well, then in y is equal to mx plus b form, it would be b is equal, this is mx plus b form. It would be b is equal to 5 over 2 minus 3a over 2. And this is my x now, so my slope, my m, will be negative 3/2 in this form, and my b will be, my y-intercept will be 5/2. Unfortunate that my y, so my b is that, my y-intercept is 5/2. I'm sorry if this got confusing, I confused myself. In any case, that is linear systems of equations, part 1. Part 2, the next video I'll do elimination just to show you how that works so you can pass your exam.
School, please dial 3136. Mr. Fisher, if you're in school, please dial 3136.
And then we'll jump into, in the third video, some word problems. So it's one thing when you're given the system of equations, but what happens when you have to actually use information to create a system that you can then solve to figure out whatever's being asked of you. We'll get to that. And that is arguably the more challenging part. Okay, thanks guys. We'll see you soon.